Hi, I'm Mark Gonzales. This is the final processor for the final project, the microprocessor. Here it is in all of its glory. It needs to be zoomed out quite a bit to fit all of it on one screen. This is the best I could do. But we'll start off each of the individual sections. Here we have how we go between the different states. We have S0 and S1. So this cycles through the different states because it's only dependent on time. That's all that needs to go into it. S0, yes, S1 is the next state is not S1, and this is the XOR of S1 and S0. You get the next states. Then we move down. This is the register for A, so we can figure out what to put into A. This is the output, so we can see what it is, and the same thing for B, and the output for B. Here is our bus. We have a ton of stuff coming in at different times, different enables, the LU in, the input in, all. And this is our bus, and that goes to, as we can see, there for A and there for B, showing things where to go. Down here we have all the combinational logic to get add and subtract on for each of the different times. A, B, C, D, and E all correspond to the different. A is instruction 2, B is instruction 1, C is instruction 0, D is state S1, and E is state S0. I just did that so it was easier for me to see, and I did all of my truth tables in terms of A, B, C, D, and E, and that just made it easier to see. Then with all the combinational logics, there's the add, subtract, load instructions, increment, enable in, enable out, enable B, enable A, enable the ALU, and then enable instruction read. Here is how I move between my data points. So this is RAM. It can store 8 bits of data. Each of these can be in hexadecimal units. So the first one goes from 0 to F and the second one from 0 to F. So the first one breaks out into the instructions, which go right here. Those are bits 7, 6, 5, and 4 on the 8-bit display. And that loads into my instructions, which are right here. And the register in those will stay throughout the cycle. And then the bits 3 through 0 go into the data matrix, the data registers, and then those will also stay for the entirety of the cycle. And then the increment turns on this counter, and the counter moves up 1 every pulse. So it doesn't move the RAM position from here to here in one during the second state. It actually moves it during the third state once the increment has gone from 1 to 0. So it moves it on the pulse. Here we have our adder and subtractor. I use the built-in adder and the built-in subtractor to save space and make it look nicer. I give a description of how each of these work in the write-up I have. But in this case, I just have my multiplexer, and the add and subtract chooses between whether subtract and 0 or the add and 1. And that's how it chooses. And then the enable ALU allows this controlled buffer to put it in. These are the ALU, and that comes back into the bus, and that will allow it to go into the bus. The registers for A and B both work on very similar ideals. They have a multiplexer that allows to connect from the bus to that same bit. And it has enable A that allows it to read from the bus. If it's 0, it will just continue reading from the same register, or the same output will go in as an input, but it's a 1, it'll take the bus as input. and that also is for B, and that's also the same for my output registers the same, except the outputs, they don't read from directly from the bus, they read from A3. A3, A2, A1, A0, and that it reads whether or not enable 0 is 1 or not. Over here I have my input. This one you can change whatever values you want. It will display on the input, and when you select the instructions to input something from over here, it will then go into the bus and then into A. I think that's everything, so we can put in some instructions. So to start, we're going to have it do nothing, and then I want it to put in the number 4. I'm going to add 6, so this would give us A in register A, and 6 would be in B. Then I'm going to subtract 4, and that will give us 6 in A. And then I'm not going to do anything, actually I'm going to send it to the output, and then I'm going to make A whatever value I put into this spot. And right now let's just make this, I like the number 7. So now we can run, we're gonna look at these outputs because this is all that matters. And now we run it. So this will just take a little while. It's running at 1 hertz. So as we can see, we just put 4 into A, which was our first command. We 6, and then we added that to A, and now we have A. 4, now we're about to take off. Now we have 6 there. So the next command sends 6 to the output, and now we should be sending 7 to the input. And that is all. That's all 5 commands, and of course now it's not doing anything. And the way the data works in RAM, it'll just repeat that same task over and over. I could have it keep adding a number to itself, but considering I input A with something, it's going to repeat the same cycle over and over. Since I could technically change these numbers and change up how this works. And now instead of the 6 will go to there, and now a C will come into A now, because that's what I put into the input. I don't know what's left to show. We can do another set of commands. I think I have to go here. We're just gonna So if I wanted to, I could put in I can put in an F. I can subtract a B, and then I can add an A if I really wanted to, and then I can put the input. Even if I do like a number that's not a 0, I can still do whatever. It's not going to change what it'll still output it. No, nothing's going to change. So this is my command. It's going to put F in, it's going to subtract B, it's going to add A, and then it's going to send what A is to the output. And then it's going to take my input and put it in. The 7 and the 2 next to the 4 and 3 don't mean anything in this. And as we can see what the RAM is there. So let's give a nice number to put into the input. I'm going to give 8 is a good number. A won't be 8. And where is it on that? So we might actually miss the first. We're gonna move everything over 1. 5F, 2B, 1A, 4, 7, 3, 2, because it was on it, and I want to make sure that we have time to see it work and not it immediately goes into there. All right. So now what we have, so this should work. So we have C in that A spot, and that should turn to an F. There it is, that's an F.
Next command should be subtracting B from it, and we get 4. The next thing should be A, and adding it to, we get E, which makes sense. Then E should go to the output, which it does, and then the 8 should go into A.
So that again is all 4 commands I needed. This does have a lot of space because the instructions, I guess 6 through F, aren't really being used. It would take, a lot of these commands would still be the same. Enable A, enable B, and enable ALU would change, and we'd have to get a different system for differentiating between adding and subtracting. But this is the microprocessor. It adds, subtracts, and puts numbers into places. And thank you.